Okay, so once again, good afternoon to all of you. So today I'm going to explain mathematics behind the artificial neural networks from very basic neural networks, and slowly I'm trying to improve the complexity of the neural network. And after mathematical discussion at every stage, I'm trying to implement the same thing using Python and also using MATLAB. So the code which we are going to discuss today, that will be helpful to understand the procedure that was happening behind the every ANN model. So till now, generally, most of the people saying that ANN is like a black box. So that we are feeding few inputs like X1, X2, and X3, and that ANN model will give some predicted output. So what happened behind the ANN model? What happened behind the ANN model? It looks like a black box. But in today's session, I am trying to open that what is inside the box. I'm trying to explain. I want to unbox that ANN model. So what will be the inside? So I'm trying to explain. Hope definitely, I'm sure you are able to understand well about um, about the artificial neural networks from the basics. Right. Fine. So in the previous class, actually, we discussed about the optimization, and today we will going to discuss about where we need that optimization in the ANN. That also we will discuss. Fine. So come to the point. So based on yesterday's session of Professor Vinod Kumar sir, maybe you are aware of that. Every artificial neural network, if you say it is an artificial neural network, so every artificial neural network generally have three layers. One is called as input layer. So one layer is called as input layer, and another layer called as hidden layer, and another layer called as output layer. So this is the input layer where we are feeding the input information. This is called output layer from which we extract the predicted output. Whereas in between input and output, there is multiple layers. Those layers are called as hidden layers because those layers will be hidden between the input and output. Between the input and output. That's why it's called the hidden layers. Okay. So every ANN will have the three layers mainly. That means three layers. One is called input layer, output layer. In between hidden layer, there may be a multiple. That is one of the hyperparameters that we are going to tune to get the better results. So there is a hyperparameter. There is no a specific thumb rule how many number of hidden layers you want to keep between the input and output. So you have to change it randomly until you got the better performance. So once again, I want to repeat, every ANN model inside, you have the input layer, output layer, and hidden layer. Okay. So first of all, today I want to start with very simple network. That means without considering the hidden layer. And slowly I want to include the complexity, improve the complexity or increase the complexity of the ANN model. So first, so let's assume I want to so there is, let us assume I want to take a one small case study. I want to consider a small case study. The case study is there are total three input features x1, x2, x3. And based on these three input features, I am trying to predict some output feature y using artificial neural network. So that is my case study. So you may take x1, x2, x3. So like for example, suppose if I am going to predict the electric power load on a particular substation at a particular time based on the load available in the last 3 days. So then what it means is, let us assume I'm going to, now time is 1:50. I'm trying to predict the load at 2 p.m. I want to predict the load at 2 p.m. on a substation. So what the approach? What the approach I am want to follow is, let's assume I'm trying to predict that load on a substation at 2 p.m. today based on load available yesterday 2 p.m., day before yesterday 2 p.m. and before that 2 p.m. So that means like that. That means I am trying to forecast the load at particular time t based on the load at 1 day before, that means 24 hours before, and load at 48 hours 2 days before, and load at 72 hours, that is called 3 days before. So you may call it as x1 is a 1 day before load, x2 is a 2 days before load, x3 is a 3 days before load, and I'm trying to predict this time. That means load at 2 p.m. today. So let us do this approach. So based on this approach, so I think you understand that we have to design an ANN model which is able to predict a output y based on the three input features x1, x2, x3. If it is a load forecasting on a substation, then x1, x2, x3 are the load on the same substation for the last 3 days. So x1 is the yesterday's load, x2 is the 2 days before load, x3 is the 3 days before load, and I'm trying to predict the load at 2 p.m. today, that is the y. Okay, so the case study is I'm trying to predict the variable y based on the three features x1, x2, and x3. So from the problem, first we need to understand the problem well. We have to understand the problem very clearly. So here a problem is I'm trying to forecast some variable y based on the three features x1, x2, x3. See, in this case, x1, x2, x3 is the 1 day before, 2 day before, 3 day before load, and whereas y is the what will be the load at 2 p.m. So that is the problem here. You can consider some other problem, like let's assume you are trying to predict whether the person has a COVID or not. Some features like fever, cough, cold, and O2 level, let's assume. If that is the case, the person has a COVID or not, that output is a predicted output, y, whereas fever, cough, cold, and O2 level all are called as the input features. Okay, so from first of all, we need to understand the problem very clearly. And later we need to identify the what are the input features and what is the output variable we are going to predict. Okay, so from this discussion, from this case study, we understand that x1, x2, x3 are the input features and y is the output variable we are going to predict. So based on this problem statement, based on this type of problem statement, next step is you are going to prepare a data set which consists of all the three input features and the corresponding output variable. You have to prepare the data like that. So then what I will do, I will go to the substation. I will take the past historical data and I have to rearrange the complete data in this format. Okay, so like that you have to prepare the data. So once that data is ready, now let us assume I want to design the ANN model. Here in our workshop, the main intention is designing of the ANN and functioning of the ANN. So that's why I'm not going about the data pre-processing techniques. I'm trying to explain about how ANN will work. Okay, fine. So from this discussion, I hope that you understand. So there is a one variable called y, which we are going to predict based on some input features x1, x2, and x3. That's how you understand. So we have the total input features 3, and we have one output variable, that is a 1. So once you identify the number of input features and number of output variables, now you start to build some ANN model. You can start to build some ANN model, ANN architecture. So how this ANN architecture will be? So I want to start from the very small model. Okay. So generally I told that ANN architecture will have the input layer and output layer and hidden layer. So out of these three layers, input layer and output layer are mandatory. So first I will start with the mandatory layers. So I want to consider an ANN model. So now you may feel I want to unbox ANN model. So what will be the inside ANN model I want to tell now. Okay, so now this is the ANN model. Inside ANN model, what you have one input layer and you have one output layer, which two are mandatory. And generally in between input and output layers, we have one hidden layer. Okay, but it is the starting step. I don't want to consider the hidden layer. Later, I will add the hidden layers also. First, I want to build some ANN architecture without any hidden layer. But you must consider both input layer and output layer. These two layers are mandatory. Without these two layers, it's not possible for you. So input layer and output layer are mandatory. Hidden layer is optional. So then you have, later we will add the hidden layers. Okay, fine. That means based on the hidden layers, your performance of the model will be increases. But at the starting stage, I don't want to include the hidden layer for easy of understanding. Later, I will try to add one by one, one by one, one by one. So hope you understand. So this layer is called as input layer, and this layer is called as output layer. Okay, fine. Now coming to the neurons. Actually, in our brain, we have neurons which are interconnected, like in ANN also, because ANN is developed based on the inspiration taken from the mimic the operation or function of the human brain. So in ANN also, we have the neurons like our human brain. Then how many neurons we have to consider in every layer? So number of neurons in the input layer, we can easily fix. And the number of neurons in the output layer, you can easily fix. But if you consider the hidden layer, you can't fix the number of neurons in the hidden layer. So what I mean to tell is, so number of neurons in the input layer, number of neurons in the output layer are fixed based on the approach what you are following. And the number of neurons in the input layer depending upon the number of input features, number of neurons in the output layer depending upon the number of output variables you are going to predict. Now, can someone respond number of neurons in the input layer for this ANN model? Anyone, please? So number of neurons in it is a 3 because we have the 3 input features. So you have to consider 3 neurons in the input layer. 3 neurons in the input layer. So every neuron will take the input from the feature. So one neuron will collect the input from the X1 feature, and second neuron will collect the information from the information about the second feature, and third neuron will collect the information of the third feature. So these two neurons will collect the information of the features X1, X2, X3 features from the data. Okay. Suppose if it is a load forecasting problem, maybe one first neuron will take the yesterday's load information. Second neuron will take the day before yesterday's load information. Third neuron will take the day 3 days before load information. So the number of neurons in the input layer, you can decide that based on the approach what you are following. Suppose if I am following the approach like I'm trying to forecast the load. Please listen here. Suppose if I change my approach for the load forecasting, I want to change my approach for the load forecasting. So suppose if I want to forecast the load on a substation based on last 3 hours load data and also based on last 3 days load data. What I mean to say is, if I want to forecast the load 2 p.m. today, I want to forecast the 2 p.m. load based on what will be the load available in the last 3 days, 3 hours. That means what will be the load at 1 p.m. that is available, because now the time is 1:56, right? On substation, what is the load is at 1 p.m. that is available. So I want to forecast the load at 2 p.m. based on the last 3 hours load data. That means what will be the load at the 1 p.m., what will be the load at 2 p.m., what will be the load at what will be the load at 1 p.m., what will be the load at 12 p.m., what will be the load at 11 a.m. last 3 hours. And also I want to forecast the load based on the last 3 days also. What will be the load at yesterday 2 p.m., day before yesterday 2 p.m., and before that 2 p.m. If that approach I am following and I want to design an ANN architecture, anyone can respond number of neurons in the input layer I have to keep?
9, sir.
6.
6. It is a 6.
6.
6 because we have the only 6 features. I'm trying to forecast the load at 2 p.m. based on the last 3 hours data. That means 1 p.m. data, 12 p.m. data, 11 a.m. data, that's the 3 features. And also last 3 days data. That means what will be the load at yesterday, 2 p.m., day before yesterday, 2 p.m., and before that day, 2 p.m. So that last 3 days load data, three features, and last 2 hours load data, 3 features. We have the 6 neurons we have to incorporate in the input layer at the number of neurons. So like that, we have to design the architecture for an ANN model. Random architecture we have to design. And coming to the output layer, the number of neurons in the output layer is depending upon the number of output variables we are going to predict. So here we are going to predict the output variable y, only single variable. So only one neuron is sufficient. So the output is coming from the output neuron. So this is called as y predicted. So this is what inside your ANN is. So this is the input layer, and all the input neurons will capture the input data, whereas the output neuron will give the predicted output. We have the only one neuron because we are going to predict only one variable, that is called as load. So as is maybe Vinod Kumar sir told in the last session, that is all the neurons are interconnected in the ANN similar to our human brain. So here also I am trying to interconnect all the neurons, input neuron and output neuron. And in our human brain, the information, when I saw some picture or some letter A, B, C, that information was stored in the human brain between the neurons. Like that also, here information is stored between the neurons in the form of the weights. So let's assume this is the weight, first input neuron, first one output neuron, W11. You can call it as a W21, and we can call it as a W31. So these are the weights connected between the input neurons and output neurons. So based on your data, based on your problem, these weights will be updated. The weights will be updated. W11, W22, W11, W21, W31 are updated such that for a given input features, you are able to predict an accurate output. You are able to predict an accurate output. Hope you understand. So this is I'm unboxing the ANN. So inside a ANN model, so the architecture will be looks like this. So your model will be looks like this. If you use the MATLAB toolbox, whatever it may be, it looks like a small box, but inside these computations will be carried on. Moreover, in order to build some relation between your input features and output feature, so we need to consider some activation functions. Maybe in the last class, Sir discussed about the different activation functions like sigmoid and tan hyperbolic and linear activation function, relative activation function, different activation functions. There is no need of connecting the activation function in the input layer. The main intention of the input layer is capture the input data. So we keep the activation function in the latter layers, in the hidden layer and in the output layer. But in the starting stage, I am not considering any hidden layer. So we have the one output layer. In the output layer, I am using the linear activation function. Linear activation function is nothing but whatever the product is coming, same will be coming as the output. Now, so let's assume x1 is a one value, x2 is another value, x3 is another value. So based on these three input features, we are trying to predict the load yp. So how we get the yp value? So yp equal to, you can see it is a linear activation function, like you can consider it as a sigma, that's it. So linear activation function. So linear function of your input features. So yp can be written as yp predicted output yp equal to so this is x1 passing through the weight W11. So we can call it as a W11 into x1 plus and x2 passing through the W21 into x2 plus x3 is passing through the W31 weight. So W31 into x3. So you can simply write this expression as x1, x2 and x3 and multiplied by W11, W21 and W31. So this is how we are going to predict the load in this simple basic ANN model. So predicted output can be written as so X matrix, that is called as the input features, and weight matrix, that is called weight matrix, this one W matrix. So X matrix values are available from the data set. These are called as X1, X2, X3 for the first sample. These are called as X1, X2, X3 for the second sample, and corresponding outputs are these are. So this X value is coming from the sample, from the input data, and W you have to randomly initialize at the starting. We need to initialize the W value randomly. We have to initialize W value randomly. So like this, we can calculate the YP, predicted output. Okay. Now, what happened during the training? So let's assume for the input X1, sorry. for the input x1, x2, and x3, the y value is y. Actual value is y, let us assume. But here we are getting the predicted value yp. Yp is called as the predicted value. The value which is available in the data is called as the actual value, desired output. We are expecting when we are x1, we are giving the features x1, x2, x3 to the ANN model. We are expecting this y value, and yp is called as what your ANN model is giving. So this y is called as the desired output. Yp is called as the actual output or predicted output. So yp is the what output, what your model is predicting. Y is the actually what you want, what you are expecting. I am expecting the y value for this x1, x2, x3. For this x1, x2, x3, I'm expecting y. But when I am giving x1, x2, x3 to this ANN model, what we are getting, that is called as the yp, that is called as the predicted output. Okay. Now see, I want to move further. So for inputs x1, x2, x3, these are the input features. So I have the y value that is called as the desired output or actual output. I'm calling it as a desired output. I want to keep it as a desired output. So this y is called as a desired output, D. But when I'm giving the x1, x2, x3 through this ANN model, when I'm giving the x1, x2, x3 to this ANN model, after multiplying with the W11, W21, W31, the predicted value, what ANN model is giving, that is called as the predicted value YP. So this is called as the actual output, what actually your model is giving, but what you are desiring, that is available in the data. So these are the input features in the data set, and y is called as the desired output, what you are expecting from these features, that is a y, and yp is called as the actual output or what output your model is predicting, yp. That is yp is called as the what model is predicting, yp. So what is now coming to the training process? Actually, what is the purpose of the training process? Our purpose of the training process is based on x1, x2, x3, the predicted output should be as close as possible to your desired output. For a given x1, x2, x3, what ANN model is predicting yp should be as more close to your desired output y. So how we measure the performance of the ANN model? That is based on the square error. Based on the square error. That means if the actual output or desired output minus predicted output yp whole square, it is called as the square. If the square error is minimum, if the square error is minimum, that means the difference between the y and yp will be minimum. That means y and yp are almost close to each other. That's what we are expecting. We are expecting the ANN model such that the model is able to predict yp, which is almost close to your actual or desired output, your desired output. So if you are predicting value, desired output, both are close to each other, both are equal, then your error will be 0. Error will be small. So our main intention is during the training process, the main intention is we are trying to minimize this error. We are trying to minimize this error. Hope you understand what I want to tell. What I want to convey with you is during the training process, what happened is the training algorithm is trying to minimize the error. So minimize the error is nothing but the square error is nothing but the difference between your desired output minus predicted output, trying to minimize this difference. So if the training algorithm trying to minimize the difference means now the model is well trained. That means the model is trying to predict the value which is close to your desired value, what you are expecting from the model. So now you can observe here, now actually the training of the artificial neural network comes like a optimization problem now. Hope you understand. It is like a optimization problem. Why optimization problem? Again, we are trying to minimize the error. Error is nothing but the square error, that is the difference between the desired output minus predicted output whole square. So if try to minimize this gap, so definitely your model is predicting the actual output, what you have. Model is predicting the value which is close to your desired output, which is available in the data. Okay, now it comes under. And one more thing, if you try to minimize this error, square error, so if I want to add one more parameter called 1/2. The purpose of keeping this 1/2, I will tell later. Just here I am taking I'm trying to minimize the half square error. I'm trying to minimize the half square error. If you try to minimize the half square error, nothing but you try to minimize the square error, nothing but try to minimize the difference between the desired output and predicted output, nothing but your model is predicting the output which is close to your desired output. All mean, so maybe the words are different, the statements are different. Final intention is you are trying to train the model such that the model predicted output will be close to your desired output. Then the difference will be minimized. Then square will be minimized and half square also minimized. So half square error also minimized. That is our intention of the training algorithm. So during the training process, what is your intention? So during the training process of artificial neural network, what we are doing is we are trying to minimize the error, square error, that's called 1/2 into your desired output for a given input feature and minus your predicted output for given input feature and whole square. Now, I think based on our day before yesterday session, you may conclude this one as, and one more thing, I want to do one more. So this can be written as I will write here. So minimize. So E equal to 1/2 into Y minus, what is the YP value? So what is the YP value? What is the predicted output of this ANN architecture? So predicted output of this ANN architecture. So that is the predicted output of the ANN architecture, that's equal to x1 into w11 plus x2 into w12 plus for w21 plus x3 into w31. So this one is the predicted output, right? So simply you can keep that yp expression here. So y in minus yp can be written as the multiplication of your input features and your weight matrix whole square. I think you agree with this one. Okay. So W is nothing but so we can further write this one as 1/2 into y minus, so W11 into x1 minus W21 into x2 minus W31 into x3 whole square. Now, can you please tell me, I think you aware that the training problem, training algorithm, training procedure for ANN model is an optimization problem because you are trying to minimize the half square error. So again, we can give some other comment like, so training of a artificial neural network model is nothing but dealing with a non-linear, because you have a square term, dealing with non-linear multivariable, you have the multiple variables, non-linear, multivariable, there is no constraints, unconstrained optimization problem. Hope you are able to agree with my statement. So training of the ANN model is nothing but a non-linear optimization problem. Again, you could call it as it is a multivariable, non-linear, unconstrained optimization problem. So why it is a non-linear? You have the square term. And why it is a multivariable? You have the multiple variables. And why it is the unconstrained? There is no constraint. This is only we are trying to do it. So now to solve this optimization problem, we require the gradient descent algorithm. That's it. So now actually we thought ANN, we started with the ANN architecture. We discussed, finally we landed in the optimization problem only again. So that what we discussed in the day before yesterday session, that concept we will try to adopt here. So before going to discuss about the backpropagation algorithm for the simple ANN model, by using the gradient descent algorithm, I want to ask one question. If someone respond, it will be happy. Tell me, in the day before yesterday problem, when I'm considering minimize f of x equal to, minimize 3x squared plus 4y squared plus 10, then I said that the variables are x and y. In the decision variables are x and y in the optimization problem. Now tell me, in this current optimization problem, what are the decision variables? or which variable will decide the error? Nothing but decision variables. Which variable decide your optimization objective function? Those variables are called as the decision variables. So what are the decision variables for this problem? What are the decision?
Y and W?
No, sir. So actually, x1, x2, x3, y, these all are the coming from the data set. Those are the fixed. We are not changing any data. For our problem, we have the fixed data. So we are not changing the data. So here, the main variables are weights. So W11, W21, W31, that means weight matrix. That weight matrix or the weights are called as the decision variables, because these three will decide the performance of your ANN model. Whereas X1, X2, X3, and YP are the outside the ANN model, which are coming from the data. So we are not changing the data. Someone will give the data as a whatever machine learning engineer, whatever it may be, we are trying to train the model. So train the model means we are using the same data X1, X2, X3, YP, but we are going to update the W11, W21, W31 such that for a given X1, X2, X3, the predicted output of YP should be more close to your actual output or desired output Y. Desired output Y. Hope you understand what I meant to say. So in our case, in this problem, W11, W21, W31 are called as model parameters. Are called as model parameters. If you thought you are a machine learning engineer, if I am like a mathematician or optimization specialist, then I call it as a W11, W21, W31 as a decision variables, which will decide the output variable, which will decide your objective function. See, so your objective function that is called minimization of error will be based on W11, W21, W31. Don't feel that Y, X1, X2, X3 are the fixed values. These values are coming from the data that will not change. The data is like that only. Only thing we are going to update is the weights W11, W21, W31, nothing but the weight matrix W. This weight matrix W is called as the model parameter matrix, or it's also called as the decision variable matrix. Right? Fine. Now we will discuss on training algorithm based on the gradient descent algorithm. Suppose if you understand the gradient descent algorithm, definitely you are able to give uh, some comments while demonstrating the training algorithm. Right. Right. Fine. So now how actually how this training process is happening. See, how the training process is happening is, so every training process you have to, step one is, so actually we have the data. So we have the data set. So we have the X1, X2, and X3. We have the desired output, actual output, what you for the given X1, X2, X3, what is the output is that is available. Let's assume, so maybe 0.1, 0.2, and 0.3. Maybe you can take it as your output is like 0.4. Let's assume, just I'm taking some random values. So 0.2, 0.3, and 0.4, your you are going to your target value, your predict output variable value will be 0.5. That means when your input is 0.1, when input is 0.2, when another input which is 0.3, then your output is 0.4. When your one input is 0.2, another is 0.3, another is 0.4, then your output is 0.5. Like that, so much amount of data will be available for you in the data you have to prepare before going to the training. So when we worked on some electric power load forecasting problem, I asked my students collect the data, real-time data. Then my students went to some nearby substation and they collect the hourly load data from 2021 January 1st to the December 31st, 2021. And we will pre-process the data and we will keep rearrange the data in this format. Now data is readily available. Now, so what is the training procedure? What is the training algorithm is? First of all, you need to read data. You need to read data. So that is called, you have to read both the input features and also you have to read your target output. Data, complete data you have to read. So X means X1, X2, X3 for all samples. Y means these things. These all are the Y values. This is one column matrix, and this is the some samples. Let us assume if there is 1,000 samples are there, then the size of X will be 1,000 cross 3, and size of the Y will be 1,000 cross 1. So that data you have to read because the data is required while training. Because on which problem you are working, the data related to that problem you have to give to your model. Then your model will be trained on the given data. From later, once it was trained properly, if you give some unseen data to your model, then it is able to predict well. Okay, so that's why I'm feeding the data X and Y. And because it is the optimization problem, so you have to read the eta. You have to read the eta, that is called learning rate. And what else we have to initialize? We have to initialize itermax. That means maximum number of iterations you want to run the training algorithm. You have to read the itermax also. And anything else we need to give? So itermax, fine. Hope. And one more thing. So in addition to the reading the data, initializing the eta value, itermax value, and also you have to randomly initialize your weight matrix. So starting you have to random initialize. So in our case also the human brain, when the child was born, nothing is available in his human brain like a random voice. So random, nothing is available in his brain. From later onwards, while seeing his mother multiple times, so his neurons will be updated, and after some time he is able to recognize, yes, she is my mother. Like that here also in artificial neural network, before training, you have to assign some random weights. You have to assign some random weights. Later, during the training process, these weights will be updated such that for a given data, your model is able to predict YP very close to your actual output Y. So you have to randomly initialize all the things. Okay. Next step 2. Now it is the iterative algorithm. So you can start with iter equal to 1. Let's assume I'm starting from the first iteration. So now what you will do in the step 3, first iteration, you have to feed the first sample, update the weights. You have to feed the second sample, update the weights. If you have the 1,000 samples, you have to take the 1,000 sample, update the weights. Once all 1,000 samples are completed, then go for the second iteration. I hope you understand. So like these 1,000 sample increment will be inner for loop, iteration increment will be in the outer for loop. Like that you have to think. So you have to feed the first data sample, update the weights W, pass the second data sample, update the weights. Similarly, you have to pass the 1,000 samples, update the weights. Once all the 1,000 samples are passed, now go to the next iteration, iteration number 2. So what is the first time? Now simply you can choose sample equal to 1. You have to feed this x1 value, this x2 value, this x3 value, and this is your desired output. You have to feed that information to your ANN model. This is the ANN model which consists some weights. So you have to feed x1, x2, and x3, and you have to be able to predict the Y values. Okay. So what next? So we have start first iteration. We are in the first iteration, and we take the first sample. First sample means maybe 0.1, 0.2, 0.3. So these are the x values we have taken, and corresponding Y value is 0.4. That also we have taken because it is sample 1. In the sample 2, this data you have to feed to your model. When sample 1,000, this data will be feed to your model. This process will be repeated when the sample is incremented. Fine. So once we feed the data sample, so what next thing we have to do is, so any idea? Maybe just we can interact. So we are feeding we take one sample from the data set, x1, x2, x3, and feeding to the ANN model. So what happened? What will be the next step? If you give that x1, x2, x3 to ANN model, next thing, what will be the next thing? What we have to do next? For ANN model, so I am giving the x1, x2, x3 first sample values. So what happened inside? So just we are going to calculate.
Inputs are taken inside and
yes. So these inputs are taken. The neurons inside the ANN model will take these inputs, will do some mathematical operation behind based on the weights, and it will give the predicted output. So we are going to give the predicted output YP equal to your inputs X into W. X into W means x1 into w11, x2 into w plus x2 into w21 plus x3 into w31. That's what I am doing here. X into w matrix operation. So it is a x1, x2, x3, and my weight matrix are w11, w21, and w31. When I'm doing the matrix operation, these two, then we have the x11 into w11, x2 into w21 plus x31 in x3 into w31. That's what's happening here. So fine, we have the predicted output. So once we got the output, next what we have to do? So step 5. So once we got the predicted output, now calculate the half square error. So error E equal to 1 by 2 into how we calculate error value? Error value is nothing but the difference between my actual output, that means desired output, and predicted output whole square. So you have to calculate this error. Okay. So once you got this, of course, you no need to calculate this one again and again. It's not required, but to understand the algorithm, I'm explaining here. So now we have. Now what we are doing, we are trying to minimize this error, right? We are trying to minimize this error. So if you're trying to minimize this error, minimize error E equal to 1 by 2 into y minus xw whole square. If you're trying to minimize, now tell me what we are going to do in the as per the gradient descent algorithm. We choose random weights, like we choose random x and y values in the last class. We choose some random x value like 2, 3 like that. No? Here also we choose the random w value. So that is the random w value. Some weights we have to consider. So weights may be like you have to consider some random weights. I said that randomly you have to set the weights like maybe minus 0.1 and 0.2 and minus 0.3. Like that you have to randomly choose an W's weight matrix. Later, we are going to update that weights. What we did in the gradient descent algorithm, we randomly choose one x value. Later, we are updating the x value. Here also, we randomly choose the w value and we are updating the w value. Updating the w value. Now tell me, if I want to update my w, I want to calculate the delta w. How we update the w value? W equal to w plus delta w. So w is called the old value and delta w is the step change. Then we got the new w value. But how we calculate the delta w? Anyone can tell how we calculate the delta w? So based on the discussion that was happening in the gradient descent algorithm. So this is my error function. I'm trying to minimize this error function. Okay. So if that is the case, how we find the step length? So try to correlate what we discussed in the day before yesterday session. So the gradient descent
Try to
algorithm.
get the optimal value from that, mean like.
That's it. So please, in our case, previously, how we decide the delta x value, step change in length for the descent variable in the gradient descent algorithm last case. X is the descent variable. We choose some x equal to randomly 2 something, and later we are updating the x value by using the delta x equal to x plus delta x. Every time we are calculating the delta x, that we are adding to the previous value. So how we calculate the delta x in the previous case? That means gradient descent algorithm. Delta x we calculated. So we calculate the delta x like I think you may remember minus
eta.
Yes, minus eta into your function which you are going to minimize dou e by dou x. Right, madam?
At value w.
Right, at initial value at x equal to x naught, right? Similarly, we are doing here also. How we update the weights of a ANN model? So delta w equal to minus your learning rate eta dou e by, because your error function dou e by your variable is not x not y, your variable is w. So dou e by dou w. That's what we are going to do. So now what is the delta w expression? So delta w equal to minus eta dou by dou w into what is the error E? E equal to 1 by 2 into y minus xw whole square. Xw whole square. Okay. Now what is the delta w now? You can further do it minus eta. So dou by dou w of this one. So here square term is there. So it will come forward. 2 will be cancelled. So you have the y minus x into w, nothing but y predicted. Anything else we have to add here? I want to do the differentiation, this part. So minus 8 like this. What will be the derivative of this function with respect to w? So that is the minus eta. So this is like a square term, right? When you are doing the differentiation, it will come forward. So 2 will be cancelled. That's right. And we have the y minus xw. Xw means yp. Anything else we have to write here? Ah, that's it. Just simple. I'm trying to differentiate this function, error function. When I'm trying to differentiate this error function, dou by dou w. So 2 come forward, 2 will be cancelled. So y minus xw nothing but yp. Anything else we have to add here?
Minus x, sir.
Perfect. So here, because our variable is w, we are differentiating with respect to w. So with coefficient we have to consider minus x. So this will become plus, and here we have to keep the x. So this is the formula which is used to update your weights. W equal to eta into y minus yp into x. So this one I want to include in the training algorithm. So in the step 5, I don't want to consider this error function calculation that's not required during the training process. So once you got the predicted output, now you had to calculate the delta W. How we calculate the delta W? Change in weight. So change in weight is equal to, you have derived the formula eta into y minus yp into x. So eta into your actual value, that means desired value, and yp, what your model is predicting, into x, that is called input features. Input feature, that is called delta W. See, so we are getting the delta W. So based on the gradient descent optimization algorithm, what we discussed in the earlier class, what will be the step 6? What may be the step 6? So, so initially we start with the first iteration. We feed the first sample data. From the first sample data, we calculate the predicted output. And once we got the predicted output, and we have the error, and we are trying to minimize that error by updating the weights. That's why we do some gradient descent approach here, and we calculate the delta W value. So now we are calculating the delta W value. What may be the next step in the training process? So these things, what I am discussing here, ma'am.
Update W, sir.
Yes, yes. So we are going to update the W. So W equal to W plus delta W. We calculate the W here, delta W, and we have the old W. So update the W. Now it is the new value. So we have to update the W. So weights are updated. So what may be the next step? So next step is step 7. So we are passing the first sample, updating the weights. Now what we have to do? We are passing the first sample from the data, take the one sample from the data, and we are going to update the weights of the neural network model. So next what you have to take for the second sample. So that means we have to, yes, you have to increase your sample count. So go to the sample equal to sample plus 1, second sample. Next, what do you think? So step 8. So you have to check if your current sample number is greater than number of samples or not. Hope you understand. That means, so you have to, first we have to give the first sample, later second sample, last third sample. If you have the 10 samples, you have to give the first sample, update the weights, second sample, update the weights, third sample, update the weights, fourth sample, fifth sample, sixth sample, 10th sample, update the weights. So you have to do it every time until you reach the maximum samples. So if this condition is not satisfied, then what you have to do? Any idea? By seeing this algorithm, suppose if the current sample count is less than your samples, then which step we have to go from here?
Step 3, sir.
Step 3.
Step 3 means again we go to first sample again.
No, 4.
Right.
4.
We have go to the step number 4. So based on the new sample, again go to the step number 4, again calculate the predicted output and compare with corresponding your actual output in the data, and later update the weights. So all the process will be repeated. Okay. So if it is satisfied, this condition is true. If this condition is satisfied, go to next step. So next step means what we will do in the next step. That means step number 9. What we are going to do? Any idea? We completed all the samples. That means that is the true case. All the samples in the data we observed, and based on those samples we updated the weights. So then
Step 2, sir.
we are going to increase the iteration. We are going for the next iteration. So we have to update your iteration count. Iter equal to iter plus 1. Okay. So here I want to write separate. So we are updating the iteration count here. Now I want to write the step number 10 here. In the step number 10, what we are going to do is check for the iteration count, whether your current iteration is greater than iter max or not. That means you are training the model, you train the model for the maximum number of iterations or not. So if it is no, we are not observed all the iterations what mentioned initially. If it is no, where to go? If it is no, that means your current iteration number is not maximum iterations what you mentioned at the time of starting of the algorithm. Then where to go here? I will.
Step 2, sir.
If it
We'll
is
go to
no,
next
Step 3. Step
next sample.
yes,
step
we are
3.
going to the step 3, not step 2. We're going to the step 3. Perfect. Again, go to the step number 3. Go to step number 3, again starting from the first sample. So we are in the second iteration, again starting from the first sample, second sample up to 10 samples if you have. So this process will be repeated. This process will be repeated until you reach your maximum number of iterations. If it is S, that means your maximum number of iterations are reached, then go to the next step. In the next step, what we have to do? So step 11, calculate the errors. See, the errors are very less and you and your client are satisfied. The performance model is very good. Then you can deploy the model for the real-time application. In case if your error is very large, then you have to do something else. So you may increase the data, or you have to do something with the data, or you have to do something with your model. So there's many parameters are there in the ANN model. You have the number of hidden layers, number of hidden neurons, different type of activation functions. You can tune all the things. You can play with all the things. So that your error should be minimum. Here in this case, we are assuming that if your error is minimum, very less value, you are satisfied and your client also satisfied. Yes, neural network error is 0.001. It's very almost close to 0. It is predicting very well. If it is okay, then deploy the trained model into your real-time application. That's the deployment. That's it. For the remaining, these all are called as the training process. Up to here, it is called as the training process. So how the gradient descent algorithm will helpful to the training process of your ANN model? I think you understood. The gradient descent algorithm is helpful during the training process of your ANN model to update the weights. Right? So I want to a small question. So I hope you understand this case study, this problem and algorithm with the linear activation function without any hidden layer. I'm not using any hidden layer. The very, very basic model. Okay, just only to make you understand, I'm considered this one. Okay, so I hope you understand this training algorithm. I want to ask a small question based on this one, this scenario. Let's assume I am giving the maximum number of iterations equal to 100. And I am giving number of samples in my training data that's equal to 10. Let's assume. Right? Then tell me how many times your weight matrix W will be updated. So small example, maybe if you understand the training algorithm, then you are able to understand this easily. Suppose
1,000 times.
Exactly. So for every one iteration, first iteration, pass the first sample, second sample, third sample, fourth sample, 10th sample. For every sample, weights are updated. In one iteration, 10 times weights are updated. For 100 iterations, 100 into 1000, 100 into 10. That is 1,000 times your weights will be updated. Okay. So this is the training process of artificial neural network. Okay. Now I am trying to explain the training process and the deployment of the ANN model using MATLAB and also using Python by taking the very simple model what we considered here. That only I want to consider. So actually for that, I have some data, small data, only training purpose. I have take this data. You can feed your own data later time. So I hope my screen is visible to all of you. In this case, I want to consider one sample data 0, 0. So this is my sample data. In the sample data, I have the features called A, B, C. based on these A, B, C values, I'm trying to predict the variable X. So some features, anything, it may be load, this may be price, this may be temperature, this may be humidity, whatever it may be, some problem. See, whatever the problem, final outcome is numbers only. Those numbers I have considered here. So let us assume I want to design and develop and deploy one ANN model to predict the X variable based on the input features A, B, and C. And I have some data. So if A value 0.1, B value 0.2, C value 0.3, my X value is 2.3. If the A value 0.5, B value 0.5, C value 0.4, my X value is 5.6. Let's assume this is the data. Okay, now what I have to do? I have to design an ANN model, and I have to train the model. And if the performance of the model is good, I have to deploy the model. So all the things I am trying to explain now in the MATLAB. Okay. So this data is completely available in my desktop, already shared in the GitHub with you. So you can practice at your home at time. Okay. Now I want to open the MATLAB. I'm going to click on the new script. So I want to save this one in the same folder where my data is available. My data is available here. So in the same folder, I am trying to. So it is a ANN underscore model underscore 1. So this is the first model, basic model. So I am trying to write the code. So as usual in the MATLAB, actually I'm using the CLC and clear all comments. This will nothing will do for the algorithm perspective. These two will help me to clear the command window and workspace. That's it. Fine. So first tell me what will be the next step. You can give the task for me. I will write the code accordingly. So what will be our first step as per our algorithm to training algorithm for the ANN model? What is our first step?
Read the data set.
Take-
Yes, you have to read the data. So for that one, I will give some file name. So file name is a variable that's equal to. So what is the name of my file here? My data file. So you can see my data file is sample data 00. So this data I have to call here. And I want to call this one using a command called xlsread. Actually, in case of Python, you have the pd.read underscore csv or read underscore xlx like that we have. So whereas in case of the MATLAB, we have the xlsread. So you have to pass that file name. What it is doing is just it will read the data available in this Excel file and pass it to the variable called data. Just I'm trying to execute this code for some time. I want to see what will be the data. Yeah. So execution completed. Now you can see the data. Now the data is available in the Excel sheet is available in my workspace now. In my MATLAB workspace that is available. My data is available. I think you are able to see this data also. Yeah, this is my data. Data is available. Okay. So read data, that concept, that task was completed. Okay. As you said, read data. Okay. Read data. That's it. So what next? What I have to do next? Any idea? What we can do further? We read the data next to it.
So randomly initialize W.
Perfect. We need to randomly initialize the weight matrix W. So W equal to how we randomly initialize. So what is the shape of our weight matrix here? Based on our discussion, what is the shape of our weight matrix? You can see here. So our shape of our weight matrix. That's what I considered here. So shape of my weight matrix will be like this. The column matrix. So see, otherwise I will go here. This one. See, for the shape of my or size of my weight matrix, 3 rows and 1 column. Why 3 rows and 1 column? Because I have the in the previous layer I have the 3 neurons. Next layer I have the 1 neuron. So 3 rows, 3 neurons, 3 rows, and 1 neuron, 1 column. So 3 comma 1. Okay. So you have to random initialize. How we random initialize? So yesterday we discussed actually random initialization of a variable. Here also I am initializing the W randomly. So first of all, I have to give the lower limit and upper limit. So your success may be from the minus infinity to plus infinity. It's fine. So I will take lower limit equal to minus 10 and upper upper limit equal to plus 10. So between minus 10 to plus 10, I want to randomly generate the weight matrix. So how we generate the weight matrix now? So randomly initialize weight matrix W equal to between lower limit and upper limit. So lower limit plus RAND rand. But what is the size of my weight matrix? 3 rows and 1 column, 3 comma 1 multiplied by so upper limit minus lower limit. See, so this is what happened. This line of code will give you a random weight matrix that values are between the minus 10 to plus 10, but the values will be randomly generated because I'm using the random function. Why I am using the 3 comma 1? Because I have a weight matrix between the input layer and output layer. Input layer has the 3 neurons, so 3 rows. Output layer has only 1 neuron, 1 row. That's it. One value I have given. So if you have any doubt, you can execute this code and see the W. So lower limit. Okay. So now see the W random weightage. This is a randomly generated weights. So starting, I have randomly generated the weights, randomly initialized weights. These are the randomly initialized weights. Maybe this is the weight connected from the first neuron to the output neuron. This is the weight connected from the second neuron to the output neuron. This weight is connected between the third neuron to the output neuron. Hope you understand. Huh? So once weights are initialized, what else? So weights are randomly initialized. Anything else we have to tell? Initialize. So we need to initialize the learning rate, eta. That's why I'm initializing at the 0.9. And you can initialize the iter max. Yes, you have to initialize iter max. That's equal to just I'm using the number of iterations as 100. So now we have to write the code. So before writing the code, I want to draw the flow chart to easily understand this complete procedure. Then you can easily write the code, right? So what we are going to do here is, so start the algorithm and read data and initialize data. So read data and initialize the data. So once you read the data, initialize the data, what you have to do? Set iter equal to 1 and set sample equal to 1. Okay. Next, what we are going to do? So calculate the predicted output. How we calculate the predicted output? Yp equal to x into w. Once you got the predicted output, next step is we are going to update the weight. So how we update the weight? So that is called w equal to w plus delta w, right? How we calculate the delta w? Delta w equal to eta into actual output y minus predicted output yp multiplied by x. So this is your weight updation. This is the delta w. I think you are trying to remember. This is called as delta w. Just I'm writing directly. So what next? Once the weights are updated, what you have to do? Check for the update the sample number. So sorry, you can update the sample number. That's better. Update the sample number. So sample equal to sample plus 1. So what we have to do here? Once the sample count is updated, check for the decision block whether your sample number is greater than the number of samples or not. If it is yes, go to next step. If it is no, where to go? If all samples are not covered, then we have to go to the YP calculation, right? And if it is yes, we are going to update the iteration count. So iter equal to iter plus 1. Next, what we have to do? Again, go for the checking, iteration checking, whether iter value is greater than iter max or not. If it is no, the max number of iterations not completed, then again go to the sample. If it is yes, then if you feel that errors are small, then deploy the model and you can stop the algorithm. So this is what happened, right? Now I will write the code accordingly. Okay. So how many for loops we required here? How many for loops required here? Inner for loop for the sample and outer for loop for the iteration. Right? So I want to do that one. So for iter equal to 1 to iter max. Maybe syntax will be changes from the Python to MATLAB, but logic will be almost same. So for iter equal to 1 to iter max and inner for loop for sample equal to 1 to number of samples. So number of samples in the data, how you will identify here? You can see here in our data, how many number of samples we have, how I get? Number of samples is nothing but the number of rows. 1 sample, 2 sample, 3 sample, 4 sample, like that the number of samples. How we got the number of rows? There is a command in the MATLAB called size of your matrix name, a data set name, comma, 1, it will give the number of rows information. If you keep the 2 here, it will give the number of columns. If you keep the 1 here, it will give the number of rows. So keep enter. So it is the 12 samples are there. So you have to pass the first sample, second sample, third sample, fourth sample, 12th sample. You have to pass every sample, update the weights. Okay. So I want to use this same command in the code now. So inner loop will be changing from the 1 to number of rows, number of samples. Okay. Now what we will do in the inside loop, inside for loop, what we have to do? What we have to do in inside for loop? Inside for loop, what we are doing here? So we are doing two conditions. One is predicting the output, and accordingly we are updating the weight. Predicting the output and updating the weight. Sample increment and iteration increment will be done automatically because I'm using the for loop, not while loop. If I'm using the while loop, I have to externally I have to increment the sample, externally I have to increment the iteration. But here I'm not doing that one. By I'm using the for loop, it will automatically incremented. So don't bother about the incremental sample equal sample plus 1, iter equal to iter plus 1. Okay. So main focus is in this case only. So you are going to predict the output from the ANN model and also update the output. So how we calculate the output now? So let us assume y, that is the yp. So yp, that is the predicted output, equal to how we calculated the predicted output? I think x multiplied by w, right? But what is the x value? So x is nothing but you have to take the first sample. Say sample, you have that is a sample, right? Sample from the data you have to extract. So data of sample sample, okay, colon. So in the data, in the first, if sample equal to 1, that means first sample, sample equal to second row, sample equal to the third row. So this is the first position is row, and this position is called the column. So now see, do you need to take all the columns from here as the input x? From the data, we have the
Only
multiple
three.
samples,
Only
only
three.
3. So first 3 are the inputs. Last one is the output, right? Last one is called as a y. These are called as x. So we need only first 3. Okay. So x equal to sample of, here we can write first column to third column. In Python, this last next will be excluded, right? But in the MATLAB, it will be included. Okay, that you have to remember. So data of sample of row from the first column to the third column. Now multiply this x with your randomly initialized weights, then you will get the yp. So once you got the yp value, what we have to do? Update the weight. How we update the weight? W equal to W plus. Anyone can tell what to be the next expression? W equal to W plus eta into desired output minus predicted output into your X input features. So tell me W equal to W plus. W equal to
Delta
W
W?
plus delta W. Delta W is nothing but I don't want to specify externally specify the delta W. I want to include inside the weight updation. So delta W equal to
0.9.
eta. Yes, eta. I already mentioned eta value here 0.9. So eta multiplied by eta multiplied by. So your desired output or output in the data. So what is the output in the data? How we get that one? Output in the data I want. Where is output
Fourth
in the data?
column in the
Yes,
sample.
yes, yes. It is the fourth column of the corresponding sample. Perfect. So fourth column of the corresponding sample. So fourth column of the corresponding sample. So that means data of corresponding sample fourth column. Okay. So minus what next? Eta into this is the your actual output or desired output available from the data minus what you have to do here?
YP.
YP, predicted output. YP multiplied by eta into y minus yp multiplied by x, right?
Yes.
So that is x is available here. Just simply multiply with x. So that will update the weights. So this process will be repeated. That's it. Close the two for loops. So no need to mention the external increment of the sample and iteration. It will be done automatically. So this algorithm will be executed for the 100 iterations and it will coming out of the loop after convergence. Okay. So once it is coming out of the loop, what we have to, that means it is coming out of the loop means training was completed. Training was completed. Okay. So next what is this? Now we are going to check whether my trained ANN model is perfectly working or not. First of all, before that one, I want to do one thing. Run this code. You can see the W value. W equal to minus 4.4, 0.9 and 9.1. Okay. Now I will continue the execution and I will run this algorithm for the 100 iterations. Then you can see the W value. Okay. So as of now, W equal to this one, right? Minus 4 point something, right? Now I am continuing the execution. So there is some issue here. Any idea what happened here? Actually, you can see X matrix is a row matrix. This will be when you multiply with this is a single number. Eta into all the things is a single number. Multiply with this row matrix. So I have the row value. Row matrix I will get. But how the W is? How the W is? Why W like that? So there is an issue actually. Actually, W is column matrix. X is a row matrix. So you can't add the row column matrix and row matrix directly, right? So what I want to do is you have to transpose X. Then this row matrix will become a column matrix. That's the matrix dimensions problem here. So you can keep here X dash. Then you can run. It is executed. So finally, so now what is the W value as of now? So this is the new weights. Sorry, not new weights. It is initialized random initialized weights. Now I'm continuing the algorithm. So execution also completed. Now click on W. See, so these are the random initialized weights. But once the training was completed, these are the weights are coming. Hope you understand what I'm saying. These are the weights which we randomly initialized. And these are the weights obtained after the complete training process of the ANN model. So that means during the training process, based on the available data, the weights are updated. At the end of the 100 iterations, these are the weights I am getting. So model deployment is nothing but that weights deployment. That's it. So if you are deploying a model for a real-time application, means just keeping these numbers there, these updated weights there in the application. And once you feed some input to your application, these matrix values will be multiplied with those inputs and it will give the output. That's it. So ANN model or any machine learning model deployment is nothing but the simply placing the weights. Simply placing the weights. Okay. So Just give me 1 minute time, please. 1 minute, please. 1 minute. So just I have a small. Sorry. So am I audible? My voice is audible now? Hello? Hello? Someone, can you please respond? My voice is audible.
Yes, sir. You're audible, sir.
Yeah, thank you. So now coming to the remaining part. So these are the weights where we started. And finally, after 100 epochs, 100 iterations, my weights of the ANN model updated like this. My weights of the ANN model updated like this. Okay. So let's assume now what I have to do, what next task? I have to calculate the errors. So I want to calculate the error, mean absolute error. So mean absolute error is nothing but so any error you can calculate, but I want to write only for the mean absolute error. Mean absolute error means for sample 1, you have the actual value, you have the predicted value. For sample 2, you have the actual value, you have the predicted value. For every sample, you have to take the absolute error between absolute difference between the both values, y minus yp, like this you have to calculate. And you have to do the mean. That means you have to take the average of all. That's what we are going to do. Okay. So how we will do this one? I want to implement in the MATLAB for calculating the error. So for all samples we have to do, right? So for sample equal to 1, 2. So number of samples are nothing but the size of the data, number of rows, right? And I want to initialize the error as 0, error as the 0 initially, and I want to add that error continuously. So what I'm doing is error equal to error plus the difference between the actual minus absolute value you had to take. So absolute value of difference between the actual value is nothing but from the data fourth column minus predicted value. You have to do the prediction here. So you can write YP prediction equal to how we do the prediction. So prediction equal to here you can see this one same code you can write here. Right? So X equal to corresponding sample data you have to take and multiply with your updated weights. Your updated weights you have to use. That means this is called as the model. W is the model now. So you have to multiply with X and later you have to calculate the error. So YP. Okay. And you have to write end. So what it will do? So every time first sample, predict the output based on the updated weights and calculate the difference between your actual sample and your predicted value. And you have to add. That means you are summing all the things. But I want the mean absolute error. That's equal to mean value, average value. Nothing but error. Sorry, not. We have to do it later at end. For adding all the errors, and you can calculate the mean absolute error is equal to total summation divided by total number of samples you have, average value, summation and divided by this one, and it will give the mean absolute error. So now I want to run this one. So how much mean absolute error I am getting? See, so I'm getting the mean absolute error almost equal to 0. So now I am happy. So I'm happy because my ANN model is perfectly working. It's fine now. ANN model is perfectly working. Okay. So now what you have to do? You have to deploy the model. So deploy the model means you are feeding the ANN model in the form of the weights to a particular application so that when the user uses those application, when the user uses that application, so it will give the prediction. So let's assume I'm developing an application now. Just click here. I'm writing the application, some application I'm to develop. So application is nothing but you have to deploy the model. Deploy the model means you have to deploy the weights, right? So what are the weights for you? So already available weights in the workspace. So deploying the model is nothing but the keeping the weights only. So these are the weights. So you have to use, so W equal to, that's it. That's it. The deploying model is completed. So deploying model is nothing but the just keeping the weights. That's it. Okay. So now what you will do? So you have your application will give a permission to the user to enter the inputs. So x1 equal to you had use a command called input. So you have to give some text information that will be visible to your user. So enter x1 value. And similarly, you have to enter the x2 value. So you have to enter the x2 value and you have to enter the x3 value. Okay, that means it will give some text display x2 value and x3 value. Once you got x1, x2, x3, how we got the prediction? So prediction, predict output. So yp is equal to, so predict output yp equal to your inputs x1, x2 and x3 multiplied by your weights. That is your predicted output. So you can write some print statement f printf. So this application I'm developing. So f printf. So predicted output is equal to some percentage. It is the floating number. You can take f comma. So yp, predicted output yp. So that's it. This is your application. Let us assume this is an application that a user uses. So once this application is executed, then what it will do? See, it asks the user. So you can take some sample from the data. So I want to use 0.4, 0.5, 0.2. Then I'm expecting 4.3. Predicted output should be 4.3. 0.4, 0.5, and 0.2. Then predicted output should be 4.3. Then what I will do here? See, x1 value 0.4. And it's asking enter x2 value. 0.5, and asking x3 value 0.2. So what is the value I'm getting? 4.3, and the predicted output also 4.3. So this is an application. You are giving the permission to the user to enter the values, is features, and your model will predict the output, that is the 4.3. So this is a very basic model. That's what I'm explaining here. So hope you understand the architecture of the ANN and random weight initialization and the training algorithm, how the model will be trained using the backpropagation algorithm for a simple ANN model. For a simple ANN model. Okay. So this is the and we will discuss with the Python also. If you want, we will discuss with the Python also. So already I shared this Python notebook with you. So this notebook I already shared with you. So here what I'm doing is actually in my TDS Google Drive, I have the data. So I want to interconnect this Google Colab framework with that Google Drive. So I'm trying to do the interconnection between my Google Drive to this Colab notebook. So it was mounted successfully. The drive was mounted successfully. Then I can extract the data from the drive into this Colab notebook, Python notebook. Right. Now, to build the algorithm, I imported some libraries like Pandas library to deal with the data and NumPy library to deal with the arrays. So this is the data available in my Google Drive. The same thing I implemented using the MATLAB, the same data. Now I want to import this data from the drive. So see, in my MATLAB, I am using the XLS read, but whereas in the Python, I'm using the pd.read_excel. I'm using the pd.read_excel, and this Excel file is available in this path. In this path, my Excel is available. So because in my drive, in this path, I have my Excel file. Just I am reading the data. That's it. So data.head means in the data I have the 12 samples. Only top 5 samples will be displayed. Data.head. That means top 5 samples only displayed, not all samples. Okay. Now actually in MATLAB, I am using the whole data for the training purpose. I'm using the whole data for the training purpose. But actually in machine learning or deep learning or when we're using the ANN, we will not use the whole data for the training purpose. Few portion of the data will be used for the training and few remaining part of the data will be used for the testing. So you have to split the data for the training and testing. So to split the data for the training and testing, I am using the train_test_split method. So what it will do, training and test and split method, it will split the data based on the percentage you have given. So I'm giving the test size equal to 0.05. So that means 5% of data used for the test and remaining percentage of 95% of data used for the training. So that means the whole data will be split into two parts. One is called data_train for the training data, data_test for the test data. So data_train variable contains the data which is used for the training. Data_test is the data which is used for the testing. So both are available here. Oh, okay. Now here doing some thing like I want to know number of samples in the training data, number of samples in the testing data. For that, I am using the command called len. So it will give the length. That means number of samples in the training data, number of samples in the testing data. And I'm converting these data into the array format. Just I'm converting all the data train, data test into the array format. So if you want, you can see number of samples in the training data, Q1. So number of samples in the training data. So we have actually total 12. Out of 12, 11 samples are in the training. And Q2, that means number of samples in the testing data. Number of samples in the testing data, only 1. So just I'm splitting the data for the training and testing. So once the training and testing data split is over, our next task is random weight initialization. See here how weights are initialized. So this is the code in the MATLAB. So this is the code in the MATLAB for the weight initialization. Where it is? Yeah. This is the code in the MATLAB for the weight initialization. I am giving the lower limit -10, upper limit +10. So in the Python also same thing. So weight, that means W, weight equal to np dot random, that means randomly initialize the weights between -10 to +10 with size of 3, 1. Why 3, 1? Because we have a weight matrix between the input layer and output layer. Input layer contains the 3 neurons, output layer contains only 1 neuron, so 3 cross 1. So 3, 1. So just I'm randomly initializing the weights. Just it is randomly initializing the weights. So next thing is, now this is the algorithm. What to write here in the MATLAB now? Here we are using this algorithm in the MATLAB. So same thing in the Python. Same thing, this is the algorithm in the Python. So you have the outer loop 100, that means 100 iterations. Inner loop Q1, that means training samples. Right? So see, you can see here in the MATLAB, we have implemented outer loop number of iterations, inner loop samples, training samples. So same thing is here. Outer loop 100, number of iterations 100, and inner loop Q1, number of training samples Q1. Okay. Now, so what you will do, we are going to calculate the predicted output, right? So what you will do here, see, we are calculating the YP, predicted output. How we calculate the predicted output? Your input features, matrix multiplication with your weight matrix, X into W. So same thing is happening in the Python also. This is the output or YP. YP or output, whatever it may be. NP dot means matrix multiplication between your features. Training features are available in the train data of the corresponding sample J from 0th column to the 3 is excluded. In the Python, the extreme variable is extreme value is excluded. That means 0 column 3 means 0, 1 and 2 only. That means 3 columns. 0th column, 1 column, 3 column. Sorry, 0 column, 1 column and 2 column. So 3 is excluded. That means in the jth sample, first sample or second sample, 0th column, 1 column, 2 column. That means 3 features. Multiply with your weight matrix. Once you got the YP or output, then you have to calculate the delta W. Update the weights. Okay. Here I am doing the both things, updating with all the things I am doing. But here it is a delta W, right? Delta W. So delta W equal to eta into your actual output in the data minus predicted output into input features. So same thing will be here. So delta W equal to eta. L means learning rate. 0.001. L means learning rate. So learning rate into. So in which column you have the actual output data? In the data underscore train file matrix. In the third column corresponding sample. In the third column corresponding sample, I have the actual data. And O is nothing but the predicted output. So that means actual output minus predicted output into, you are going to multiply with your X. X means data underscore train of the corresponding sample from 0 to 3. But it is a row matrix. I'm trying to transpose it. Like here, I'm transpose this one, right? So similarly, here also I am transposing. Once I got the delta W, dW, change in weights, then update the weight. The weights equal to weights plus delta W. That's it. So this is the training process. Now I want to do the predictions on the test data because I have the one sample in the test data. Predictions is nothing but the calculation, right? So dot product between, that means matrix multiplication between first 3 columns, that means 0, 1, 2, that means features into weights. That will give the your output, right? So that output I am storing here. So for the testing data, the predicted output is this one. And the testing data, I will do one thing. So where the test data here, right? So Control C, Control V. So this is the test data. In the test data, the actual output is 4.1. The predicted value is around something. So then what are the error calculation? We will do one thing. Okay. So you have to train the model. Sorry, you have to find the outputs based on the predicted training data. These are the outputs, but sorry, the performance is not good. You can see, so you can calculate the errors also. So your errors are very large. See, your errors are very large. 7.83, 2.86, like that, very large. So, but when I'm executing the code in the MATLAB, I'm getting the error almost equal to 0. What things made me large error while implementing in the Python? Anyone can give some comment on it. You can see errors are 7.8 and 2.8. Training error and testing error in case of when I'm using in Python. But when I'm using in the MATLAB, I'm getting the error almost equal to 0. Why? Any idea? What went wrong for me? Any idea why my performance of this model mark now? Why? What difference from there to here? Okay, syntax is different, that's fine. Logic also almost same, but still I'm getting the 0 error here, but here not like that. It's not problem with the platform. I did a small mistake. I have to do something else. What it will, anything. You can see in the MATLAB, I'm choosing the learning rate as a 0.9. But whereas in case of the Python, I'm choosing the learning rate as 0.01. So I have to keep this learning rate as a 0.9. And I want to rerun all the things. Random initialize, weights, and train the model with the learning rate 0.9. Now do the testing. Now feed the testing data and check what the output you are getting, 4.1, and your testing data output also 4.1. You are getting same almost. And on the training data, what are the predictions? These are the predictions. Now calculate the error. So actually I am using the mean square error. You can use the mean absolute error also, no issue. You can use the mean square error. I'm using the mean square error here. So mean square error, you have to pass the actual data and your predicted data. So you can see the errors, what the errors you are getting. So you are getting the errors as so almost equal to 0 here and almost equal to 0 here. Now I am happy with my errors because they 10 to the power minus 5. That means 0.00004. It is also 0.00009. Right? So now errors are okay. Now I'm trying to deploy the model. So deploy the model is nothing but just keeping these weights here. That's it. Here. So that keeping the updated weights here, that's nothing but deploying the ANN model. That's it. So deploying ANN model, deploying machine learning model is nothing but just deploy the model parameters. So in ANN, model parameters are nothing but the weights. In ANN, model parameters are nothing but the weights. Now run this code. So what it's doing, same format. I'm taking one variable and I'm calling the user, enter the value. So user will enter the value, all the values captured by a variable, and that variable passing to the matrix multiplication. Because x into w is the output, right? So you can see the data. So actually, here we have the data. Some data you can consider 0.3, 0.4, 0.5. Then expected value is 0.7. So I'm taking the 0.3 and 0.4 and 0.5. So the output is 4.69, almost equal to the 4.7. So the model is working well for this data, for this model. Don't think that this model is applicable, performing well for all the data. Okay, this is the model is well trained for this data only. So if some other data is there, you have to retrain the model based on the new data that is available. Okay, so the first session I have, actually there are many notebooks are there. First session is mainly we are concentrating on the basic ANN model without any hidden layer, but we are considering the only linear activation function and without any bias parameter. So this is how we discuss the training algorithm, and also we discuss the implementation in the Python and discuss the implementation in the MATLAB. So now it is the 3:20 and we will take a break for the 15 minutes. Meanwhile, for 5 more minutes, if you have any doubts, so let we discuss. So if you have any doubts, please tell me. We will discuss on that one. If you feel
Sir, good
any,
afternoon.
madam.
Sir, how do you choose this learning rate, sir? In many cases, I have seen the learning rates less than 0.9, but
Right.
but when
That's
you,
why.
I know that
Sorry.
when we keep 0.9, we'll definitely get the predicted value close to that one. Actually,
Madam, actually, when I'm
uh,
taking initially, I choose the learning rate value 0.001.
uh,
I think 0.001, very small value.
mm, mm, mm.
Okay, just you are
But
able to
how do you
understand. So,
choose it? How do you?
yeah.
Any
Madam,
calculation for that also?
no
Do you have
calculation, madam.
to?
Actually, learning rate should be between the 0 and 1 generally.
Uh,
So what happened in my previous case is, let's assume the optimal weights are landing here. Let's assume my error function is like this, and I'm choosing the learning rate as a 0.001, and I kept the maximum interest equal to 100. So I'm taking the very small learning data, madam. So it will be
I
started
understand,
from
sir.
here.
Yeah.
It is
But still,
slowly updating,
sir,
madam.
but still, it is it good to keep 0.9, sir, learning rate?
No, that's why I'm telling, madam.
Mm.
Because this very small learning rate, it took the more number of steps. So maybe after end of the first 100 iterations, I will be landed somewhere here. I'm not getting the best value. I was stopped here only because of the small learning rate, small steps. For the 100 iterations, it will stop here only. But when I'm taking the 0.9, so what happened because of the large step length, so it will be reaches to this point.
Yeah.
But that is why it's not performing well in my case, 0.01, I'm getting the error large. But when the 0.9, it reaches to this point very early. But I'm not suggesting that you have to choose 0.9 always. Sometimes it may create some oscillations, as I said earlier in the morning in yesterday session. It may create some oscillations around the final point that also. But luckily, I'm getting the 0.9 perfectly working fine for this case. So, but actually, the 0.9, we have to choose something. If it's not working fine, you have to adjust that learning rate manually when we are using the simple gradient method. But actually, there is some adaptive learning rate methods like RMS prop, order delta, RDM. So you have to choose very large value initially. Later, it will be updated slowly as per the data requirement.
Okay, sir. Fine.
So actually, we have to tune it manually if you use the stochastic gradient, momentum, or Nastran accelerated methods. But there is adaptive learning rate methods also there. I'm using the simple gradient method. That's why I'm tuning the eta. But if I'm using the adaptive learning rate, I no need to tune the eta. I have to set the eta value very large. It will be updated automatically based on my requirement.
Okay, understand. All right,
Thank you.
Yeah, thank you, sir.
So anything else, please? Okay, now it is a 3:25 and we will meet by 3:40. So in the afternoon session, that means in the second session, we will work with bias parameter. That means till now we consider the model parameters as the weights only between the input neurons and the output neuron. Now I will add the bias parameters also. So later one by one we are going to move further. So I will pause for 15 minutes and by 3:40 please join.
Okay, sir.
Yeah, thank you, sir.